and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today we have Cliff Crosland. He's the CEO and co-founder of Scanner. Is it Scanner.dev, right? Not just Scanner.dev.
Yeah, Scanner.dev.
Scanner.dev.
That's right.
Yeah. So hello and welcome. We were supposed to have your partner on, but something came up. So hopefully we have enough material with you to cover the hour, but I think there's more than enough based on our interactions. Why don't you give a quick introduction about yourself and what is Scanner.dev?
Yeah, absolutely. So my co-founder, Stephen Wu, and I, we were at a startup previously to the startup that we founded here. We had a massive Splunk bill, and we just started to move logs into S3. We felt like there was a much better way to interact with S3 logs and provide extremely fast search on S3 logs. And we've discovered that security teams really have this problem intensely. And so we founded Scanner.dev, but everything is built in Rust. It's just, it's been a really delightful experience. There are definitely like pros and cons for sure, in particular like the compilation time. But yeah, Scanner.dev is a serverless log management system that uses S3 to very quickly analyze and search through massive amounts of log data. And for teams that need like a year of logs to do investigations or keep a year of logs for compliance purposes, it's really hard to be a security engineer today and to find advanced persistent threats, et cetera. Like having a really low cost, extremely efficient solution to scan through lots of data quickly is really important. So we found a really cool fit between AWS Lambda functions and Rust, and also just like ECS containers in Rust. Lots of fun stuff. Like everything is in Rust except for the front end, and we're starting to introduce like a little bit of WASM and Rust into the front end in the coming few months as well. So yeah, super huge fans of Rust, and there are so many different reasons why we love it, and are very, very grateful to everyone who works on it.
Yeah, we're talking a little bit about why Rust, and you had some kind of firsthand experience about why Rust would make more sense. Can you tell us more about that?
Yeah, absolutely. So at our prior startup, we built this system. It was this intelligent executive assistant. It's called Encoding. It was acquired by Cisco a couple of years ago. But one of the products that we focused on was crawling the web and then building these intelligent briefings to send to executive and salespeople to prepare them for meetings and to do things like, oh, there's a bunch of news on a particular company you're about to meet with. There's a giant news spike. Just highlight interesting insights for people. And we built a lot of our infrastructure in C++. We had like a lot of Google DNA in the founding team. And so not me, but our CTO scaled up Google Analytics using a bunch of cool C++ work. But we had a downloading system, so a system that interacted with the internet, our crawler microservice, which handled a huge amount of work. And we discovered some really weird looking segfault crashes eventually. And as it turned out, there were a couple of memory safety bugs in curl. So we were interacting directly with libcurl in C. And it is not that easy to use. I mean, this is something we can talk about a little bit further, where like the interfaces between dependencies in Rust is just amazing. It's much easier to know who owns what and who's responsible for memory safety and freeing things and allocating things and what you have to deal with. But anyway, so with curl, it took us some time to use curl in a way that we were able to get it to be really fast and use very like little CPU and memory to like go and crawl the web like at a pretty massive scale. And we were seeing some memory leaks, and we're like, okay, maybe that's our fault. Maybe that's curl. We're not totally sure. But then once we started seeing these seg faults, we got scared, jumped into the GitHub issues, discovered like other people reproducing a similar kind of thing. We submitted a patch to help out. There were some things related to it was a couple years ago, so I'm trying to remember exactly the details, but it was like about basically TTLs and connections being kept alive. And so I think curl is an amazing tool, but it did terrify us that, it is definitely possible for even libraries as widely used as curl to sometimes experience memory safety problems or thread safety problems. And like, no matter how good you are, it'll happen eventually, like with C or C++. And so we patched it. We we tried to help like resolve the memory safety issue that we ran into and fix this time to live problem. And I think there was another like cool patch that we put into curl for telnet anyways, there's we have a lot of love for curl. I'm not trying to like diss curl. I really think it's an amazing piece of software. But it just demonstrated that it's very hard to stay memory safe and thread safe. Like even the best programmers in the world do this. So we ended up taking this crawler service and rewriting that from C++ to Rust. And it was awesome. Like a lot of the memory leaks went away. Now, like Rust isn't perfect for this. Like you could definitely have memory leaks in Rust, but just the way that Rust requires you to think about ownership and sort of structuring all of your data structures as a tree instead of a graph means that it's much easier to free things and let things go out of scope that need to go out of scope and keep memory low. But anyways, like CPU performance is awesome, memory performance is amazing, and we stopped having those memory safety issues. So no more weird seg faults that like terrified us. Because like we were hitting the internet really hard, and we were terrified that this would be an attack vector if someone could manipulate like a memory safety bug in a well-known library. This would be really scary. So for the most sensitive part of the system, or the system that interacted the most with sketchy servers out there on the internet, we felt like using Rust was a big win for us there, because we just felt like way more confident, way more secure once we moved from C++ to Rust. And now it's like, okay, I love everything in Rust. I love to like keep staying in that environment. Anyways, we could talk about a lot of cool things about Rust and the crates and dependency story. But I've definitely converted from C++ to Rust. And I think video game developers might be upset with me, but for like web development, or I guess like, sort of cloud infrastructure projects, I think Rust, and also Go, but like Rust is a really awesome choice. We've really been super pleased with that at Scanner.
I mean, you touched on so many different topics. It's hard for me to kind of segue into different areas. But I find one of the most interesting things is that it's quite important, right? Curl's like one of the most popular projects that I can think of. I mean, like everything has it in there. Like even if it has nothing to do with anything, I don't even know how to even say it, but it's always like has some piece of curl in there, and it's not just the binary that people are kind of used to in the terminal, but also the library itself, right? Like as what you're using, it sounds like. And
yes, that's true. Libcurl directly.
Yeah, libcurl. And like the crazy part is that this thing's been, I just looking it up over here, it's almost 30 years old, right? And it's so battle tested. And when I had Daniel, the creator of curl, on here for the first episode a long time ago, he was talking about how like NASA and stuff is using it. So it's like all these companies are using it. I mean, when you found some issues, like, I mean, I don't know. I would have a hard time to see if it was really me that would be doing it wrong, because it's been so widely used that it seems crazy that you guys would find a bug, right? I mean, was there a lot of second guessing? Like, are we doing something wrong? I mean, was it just
definitely.
How did the process go?
Yeah, we spent so much time digging through our own code, and then eventually just jumping into the GitHub issues, it seemed like other people had encountered it as well during a particular release. And really, curl is incredible. It supports not just HTTP, which everyone uses it for, but it just a lot of legacy protocols. It's really remarkable and so versatile. And so it kind of makes sense that, okay, it's at a certain level of complexity, there's no way to avoid memory safety issues forever. So it took us a while, but I guess like combined with what other people were saying, and like the reproduction test cases that other people in the GitHub issues were bringing up, and then us like with our use case looked very similar to that. We were kind of pushing curl really hard. I mean, I have to remember all of the like funky the funky interfaces we were using. We were using sort of like the advanced, like the most advanced ways that you can use curl to do a lot of parallel concurrent requests just at high scale. So like if someone were to run into it, it would be maybe teams like us who are crawling the web heavily. But it was like we definitely had to. We spent a lot of time making sure it wasn't us. And I'm sure and we definitely found memory safety problems in our code over like so many, like countless over the years in C++ there. But yeah, it just demonstrated to us that like no matter how good you are and how many eyes you have on a C or C++ project, it's just so much harder. It's just so much harder than Rust in particular to ensure memory safety. Like you rely on really good code reviews basically as patches go in. But in Rust, the compiler also helps you. It's not perfect, of course. Like you can definitely use unsafe everywhere. But it just, I think it's like at least an order of magnitude more like memory safe. It's just so much easier. It's got to be like probably a couple more, a couple of orders of magnitude more memory safe than C or C++. So yeah, it definitely, and I guess like, be another reason why we doubted ourselves for a while and wondered if we were doing it wrong is the only way that you sort of enforce the contracts of who owns what memory and thread safety contracts, like what structures are and what pointers are okay to pass between threads, is just by reading the documentation. So you might see like a function in libcurl or like something that like graphics magic or some of these other like C or C++ based libraries that say, cool, for this function, you own the pointer. You've got to call this particular function when you're free to free the memory that the pointer points to. And in other cases, it's like, no, we own this. This is just a reference you can look at, and we will free it later. And it's not always clear from a code review. Like you have to not only read the code in C, C++, but you also have to open the documentation, and your reviewers have to be really familiar with the libraries. So to enforce the memory safety and thread safety contracts in C and C++ is just super hard. Whereas in Rust, it's like, oh, I compile this, it runs. If the authors haven't done anything crazy, we have all done our part appropriately. We're like, I'm owning the memory in this case, they're owning it in that, and the compiler helps enforce that contract instead of developers. So yeah, just like we really love that about Rust and have just really invested heavily into using it at Scanner for sure.
Okay, yeah, those are really good points. And as we were saying before, like so many people keep talking about, oh, it has this, it has that, but you actually have the real world use case. You found stuff, and it definitely influenced your thought process. So when you started this new company, right, that you took all that knowledge from before and said, okay, this is what we're going to use. That was just kind of immediately to you. There was no like checking around, because sometimes you learn about Rust, or you enjoyed your time over there. You start your new company, or you start your new position, and you still have to convince those around you that what you think is good is good. And sometimes even if it is good, the greater good of working together is more important than that. So you still stuck with, you know what I mean? And you're still stuck with with what the majority wants to work with, right? I
Mm-hmm.
mean, yeah.
Yeah, definitely. I think it is a tall order to as a developer to introduce Rust into your code base. I think for tools like ours, so like data analysis tools or like observability tools, security tools, you'll see Java a lot and you'll see Go. And so I think, but Rust is increasingly you're starting to see that more and more in our space. But yeah, it is. It's pretty difficult, and I would definitely agree with the sentiment that it really is beneficial to keep with convention instead of introducing new languages and new frameworks all the time. Even if like an interface, if you're just talking about a convention that you have in your own code base, if an interface isn't maybe the best or ideal, instead of trying to fix some aspect of it and then kind of make things inconsistent and confusing to people at your company, it's very good to like accept a convention that everybody shares. And so, yeah, I think it can be tough to introduce Rust. At the prior startup, we introduced Rust in just that one microservice, and that was fine. It was like very self-contained, and there was a good business use case, which is like security. We don't want memory safety problems there. And also, it was small enough that we had a lot of freedom to make that choice. But at Scanner, we actually have a blog post about this. We felt like, what we do is like the amount of data that security engineers have to handle is absurd. And observability teams, it's like a petabyte, or it's like hundreds of terabytes potentially that you have to scan through. The only like reasonable low cost place to put that is in object storage somewhere like S3. But scanning through that with like Python or something is brutally slow. Or even using Java, it's fine, and there's a lot of AWS support for things like Java. But like what we really felt like was necessary is instead of allocating a huge number of CPUs that sit there idly until someone executes a query, we felt like serverless functions gave you the ability to spin up, the idle compute in an AWS data center to do like a massive job very, very quickly, and then spin back down again so you're not really paying for it all the time. Because like log queries don't happen that often. When you're doing an investigation, it might happen like a couple of times a day. So you don't need a bunch of idle compute sitting there. And we did a bunch of experiments to measure the performance of Python, Java, Go, and Rust. And Java was really bad in Lambdas. I was surprised actually. And it's even with AWS has some things to kind of make cold starts better with Java. But like Java really needs a lot of time to boot up and warm up. And it uses a ton of memory. Whereas Go and Rust, they both like in a Lambda function, they take maybe like 30 to 50 milliseconds to boot up. Whereas in Java, it was potentially multiple seconds before like the program was fully running, and the amount of memory used or like needed was extremely high as well. The JVM is just a big beast. I think Java is still a great tool for doing CPU intensive tasks. There are some Java wizards out there who can get a lot of CPU performance out of Java that is just as fast as people like doing crazy stuff with Rust, or like close to as fast. I think it's still easy to do faster stuff in Rust, but it's like almost impossible to keep Java's memory usage down. And so for us, we're like, well, oh my God, we're going to launch a lot of Lambda functions at the same time. You spend a lot of money, or like you spend money on the basically how much memory each Lambda function is using. So if we can minimize the memory to basically like the essential bare minimum that's required to do the job, it was trivial to do in Rust. Like you could get in a really good program running using like 20 or 30 megabytes, whereas Java seems to need at least a gig to do anything. And so it was just very it's very hardware efficient. I think like Rust was just really great there. So we definitely looked around when we were starting Scanner to see like, okay, which language should we try out? And we felt like Rust and Go were very good. Go would probably have been like a decent choice for us, but one of the important things that we faced was a huge amount of thread concurrency, and security was really important to us. And we just felt like it's very easy to get thread safety out of Rust, and you can definitely shoot yourself in the foot with Go more easily. But anyways, I definitely feel like if you're doing something at scale on a massive data set, use Go or Rust. And if you need a lot of threads, like use Rust. But there are big trade-offs there. Like Rust compiles much more slowly than Go, which is the worst thing about Rust. But it's not that bad for us. Like I don't mind. Our code base still compiles very quickly, but I could see someday it being annoying. But I think the trade-off is still very much worth it for us.
Yeah, that's always one of the biggest criticisms about the compilation time. But it's like, well, you got to balance, right? And I don't know. There is like when you're in development, obviously you can have an unoptimized build. You can, I think now that we have that, what do you call that? It's not called generational. What it was? It's incremental build, right?
Yep.
So you already get most of that stuff built already, to a certain extent. So there's already quite a lot of stuff, and then it's like, well, just kick it up to the CI and then let that build the release build. You don't. We're not back to that XKCVD comic where everybody's sword fighting, waiting for the thing to build anymore. We're past that time. And I want to also touch back on the Java stuff. It's like crazy for me to understand, like, why the hell there's so many jobs. So I'm in Hong Kong, this huge banking place. If you have to basically work with Java, and I find there's so many jobs out there that have, like, as you were talking about, like you have to have these extreme Java skills where you have to do low latency, low memory Java. It's like, well, why the hell don't you just do C or C++ at this point? because that's
Yeah.
basically what you want. Because otherwise, like, yeah, I mean, you need so much skill to do that as opposed to doing something that is less memory intensive, you know. And then like, oh yeah, you
Mhm.
know, you get this like JIT. Well, you get AOT, which I think is a little bit better, right? Nobody wants to have like a sudden slowdown and then speed up. And sure, okay, if you keep it running, but then software mutates and changes over time. So no matter what, you're gonna have to do an update at some point. And then you still have the stop the world garbage collector. I think that hasn't changed yet. I mean, I'm a little bit surprised about that part. So there's so many like benefits, but I guess then maybe you could theoretically have some benefit where it's like, well, I'm not releasing my memory now, so then I'm not gonna like waste time on CPU cycles on that. Yeah, but then when you do need to release it, you'll be wasting a lot of time at maybe a very critical
Hmm.
moment, right? So I don't know. You kind of balance it out. I just don't see Java as being as successful for so many things that people are trying to use it for. You know, it's like the Swiss Army. They're trying to use Java like Python. You know, Python you can use so many different
Hmm.
places, but Java is just not good for everything. Even though it's still weird because let's kind of go back to the data science part. Is it Scala, which is based on the JVM, is actually used in data science, and that part is also a little bit confusing to me. Do you have any insight about what that's all about?
I mean, that's a good question. So our one of our engineers from Twitter used to do a bunch of work in Scala. One of the if you thought like Rust compilation times are bad, like try to have like a massive, multi 100,000 line Scala project to compile. I think Scala functional programming is really fun. I think Scala provides a really cool story there. And it might be I haven't done a huge amount of data science, but I think like I can see how if you're doing just transformation after transformation on data, it can be really fun to write your code in a functional programming like paradigm. I love Clojure actually. I really enjoyed using that for a while, but I got sick of like how much memory those programs would use, and also I kind of miss the strong typing. So Scala kind of has strong typing. Plus the benefits of just a huge number of libraries in the JVM ecosystem. And I think like really that's likely why most people stay in the JVM. Plus it is just frankly easier to learn than Rust. You can let things just get garbage collected. You don't have to fight against a borrow checker. And also like generic types. There are some kind of interesting trait things that we do in our system because we have when you execute a query, you have to build like an abstract syntax tree, and it you have like a bunch of different abstract components that need to work together, and so we use a lot of traits. I feel like that would be a little bit more straightforward in Java, with like interfaces, polymorphism, etc. We have to do we have to do some weird things with a significant number of traits, like all listed out for a given data type. So I do think there are certain things that are a little bit simpler in Java, but then I totally agree with you. Once you get to building things that are super low level, where you need really great performance and really efficient memory usage, you have to start doing a bunch of weird tricks to get it to be fast enough and efficient enough. Where like Rust just kind of you just happen to have really good CPU performance because like you're using L1 L2 caches really well because the data structures are well suited to sort of batching things in. You're not like traversing a heap all over the place. Anyways, there are just a lot of cool things that we really like about Rust. And I think like maybe Java's async story is a little bit easier than Rust's. I think it's fine for us, honestly. I think that might be like the biggest one of the other places, in addition to like bad compilation times where people complain about Rust, is the async experience. But I find it awesome. Like maybe we just use really good libraries that have like a decent async interface, and we don't really run into too many troubles there. But yeah. Anyways, I think it is interesting. I think like the JVM it is too bad that there are so many jobs. I really would love there to be more Rust jobs, but I don't know. I think I am uh, uh, like very happy to see companies like AWS embrace Rust more. The Firecracker VM that powers Lambdas is written in Rust. I've heard like a lot of S3's infrastructure is moving to Rust because it's just easier not to shoot yourself in the foot. So yeah, I think there's a good future, but it'll take some time before people start to do a lot more work outside of the JVM, outside of Java, outside of Scala, and starting to use Rust more. At least I hope so. I hope it moves in that direction.
Yeah, I mean, it always takes time, right? You were talking a little bit about video games before. It's an interesting kind of small segue we can do. Uh, there's still so much work to be done, and like as we already know, like C has taken out the majority of video game development, and but I think that for data sciencey stuff, I think Rust and Julia are definitely catching up big, right? The especially Rust. I mean, Julia is, I think itself is a data science language, right? So of course it's going to be nearly there, if not there, because that's what it is. But Rust is kind of yeah, it's definitely catching up, and I guess it's probably due to all that memory safety and everything else happening. Um, I saw an interesting thing. I guess this is kind of related, right, to Scanner.dev because it is about kind of some of data science is about searching unstructured data, right? So, yeah, in general, I know that I saw that there was a study that I think it was. I have to go back and look it up, but something like Rust is like the top growing language for data science. I thought that was pretty interesting because yeah, it's always been C++ kind of backing Python or R or of course Julia is rising, but they said like something like the fastest growing is Rust, and I find that super amazing. And kind of again leaning back to the episode with I'm sorry, I don't remember which episode this was, but I think this happened quite a few times. Some people have found that adding Rust to their project is bringing more people to their project to kind of help out because it does find it to be easier. Because it's kind of weird. It's like it's both an somewhat easier language, but at the same time, it's also more difficult because you do have this nagging borrow checker that basically, as I would call it, Stockholm syndrome you into obeying the rules. And but it's kind of weird because then you kind of see this benefit. There's a mutual benefit to this.
Yeah, I definitely agree with that. I think one of the things that everyone or sort of underestimates, especially in a C or C++ project, is how much you have to do testing in even like in production, in staging, before you fully reveal your borrow checking, like your ownership, your memory ownership problems. It is it's just this extra friction. Like maybe you can prototype much more quickly in C or C++ because you don't have a borrow checker to tell you not to do what you're doing. And in fact, like a lot of unsafe or like undefined behavior kind of works a little bit. Like if you use a pointer that has just been freed, it might actually work okay for a little while because maybe the memory that it was pointing to is kind of still there, hasn't been reused for something. And so I think like you don't have this borrow checker yelling at you. You can kind of like make progress faster in C or C++. But for like a large scale production system that has to do a lot of data science, data infrastructure engineering, you will spend a lot of time like banging your head against your desk trying to understand where things went wrong with your ownership model. Whereas Rust forces all of that to happen right up front. So like I think like another example I remember from this like downloader service, but was that sometimes when you're shutting down the service to like deploy a new version or something, shutting it down would segfault every now and then in C or C++ because our ownership model was a little bit off and was only off for like the microseconds as things were winding down. Like the order in which we were shutting down different parts of the different components in our C++ project was a little bit wrong. And things were still available that shouldn't have been, or were still referenced that shouldn't have been. But most of the time it shut down cleanly. But every now and then we'd see a weird seg fault in the logs and be like, what's happening? And it was really hard to try to debug, like, okay, well, to debug this, let's try shutting it down and see what happened. Okay, well, let's try shutting it down again. And it was just really annoying to try to fix that. Whereas in Rust, like the borrow checker immediately. So when we moved over to this new like crawler service, the borrow checker immediately said, "Oh, the way that you're like shutting down is not safe. You must put this entire part of your infrastructure and then own it in a different way, such that when the main function, when it goes out of scope in the main function, everything is okay. And that was like really revealing. It helped us actually like starting to move it to Rust, helped us debug and understand our like where the problem is coming from in C or C++. So yeah, but it's really cool. I think it's interesting to see how much it's developing and how much Rust is picking up in like the data engineering and infrastructure space. So like you have cool projects. I'm trying to remember them all. Matano is one, which is really cool. I think it's written in Rust, which like helps people transform different log sources and put them in Parquet format in S3. There's Data Fusion, which is really cool. It's sort of like a it provides a lot of database-like functionality where if you're trying to build your own database from scratch, you can use a lot of functions that Data Fusion has to accelerate that process, and that's all written in Rust. And I think who was it? I think it was there are a couple of really cool projects that have recently moved to start using Data Fusion. I think InfluxDB is one. But yeah, you're definitely seeing like Rust sort of take over a component of a really important project, like this, database sort of engine or like core engine part that Data Fusion I think is doing in InfluxDB, if I'm not mistaken. And I think that's probably like a good way for Rust to get introduced into projects and like you're saying, like make the projects more popular. Because I think it is actually kind of a joy to use Rust despite the borrow checker and despite the long compilation times, because you just feel so much more confident that what you push to production is going to work and not have weird memory safety bugs. Like in C or C++, it's pretty scary to like put something that interacts with the internet at scale out there and like feel like I think there's still a seg fault problem. Like, and I'm not totally sure. And it's going to take us a really long time to uncover that. And maybe we're willing to risk it because it only seems to happen during shutdown or something. But it's like, it feels very uneasy. Whereas Rust, I feel like, if it works and it compiles, there's like there's several classes of bugs you're not going to have to deal with that are really, really painful in C or C++. And like Java kind of solves them just through the way it's designed. But then in Java, you're going to have to really like smash your head against the desk to try to get CPU and memory to be efficient, doing kind of weird, unnatural things in Java. So I don't know. I think like Rust forces you to make those investments up front in your development cycle. And as a result, like there is more friction. You can't like iterate quite as quickly or like prototype quite as quickly in Rust. But the things that you do deploy, you can be like a lot more confident in. So I think that's like a fine trade-off for us. And once you are really comfortable with the borrow checker, I think prototyping is actually quite fast. And you realize like, oh, I can put a lot more in a vec than I thought. Like I don't have to build a really weird like, graph with like, RC, ref cells, etc. A lot of stuff works well with simple data structures, like better than you think. The B tree map, etc. I think just like a lot of cool things you get out of Rust that just requires a little bit more time investment during the dev cycle, but is like worth it in the end. It's like eating your vegetables. Like it's kind of annoying, but it like you appreciate the health of your code base over time if you do those like healthy things up front.
Yeah, I mean, let's kind of. I don't want to, because we spent so much time talking about Rust itself. I don't want to kind of miss like the main topic, which is Scanner.dev. I don't know. Like, I guess we can kind of segue in this way. You're talking about kind of like getting performance a bit and how you can do things. I mean, how do you guys choose what to optimize and how do you actually optimize? And have you actually found a lot of interesting things that say were not documented that you just kind of found out based on just trial and error, or maybe accidents or things like that?
That's a good question. I think one of the things that we found really surprising at first was how absolutely essential serialization and deserialization is. So and getting and using the right format there. It's so using things like zlib and gzip for compression. So like basically the problem that we have is that we have a massive amount of data. We want to compress it because we don't want to send a huge amount of uncompressed data over the network. We want to really reduce how much time we spend pulling data in. But like if we also need to optimize how little time we spend decompressing and then parsing that data. And one of the things that we've discovered is in Rust, because of the Serday sort of framework, you have a lot of really cool alternatives that you can very, very quickly play with to experiment between different kinds of data formats. So in one of our blog posts, we talk about like how much more quickly you can like parse data in JSON, that's like JSON parse data. And we briefly mention if you optimize and use and really try to get like a data format that's even faster to serialize and deserialize than JSON, you can get like an order of magnitude more performance. And so what we found is like, okay, so let's build these structures that we have internally in our code base that we have in memory, and let's all make them implement or derive serialize and deserialize from Serday. And that what like one really cool thing that you get out of that is like, okay, let's try this. Let's try just using a JSON serialization and see like if we put a bunch of JSON on disk and we make all of these data structures JSON like, and we have these index files that we traverse in chunks extremely rapidly. What does the performance look like? And then let's try a bunch of other options. And there are so many cool like serialization libraries in Rust. I think a lot of people really love optimizing things as like with an insane obsession in Rust. So like how can we use SIMD instructions in our CPUs to make like serialization and deserialization even faster? So we actually landed on bin code, which is like which is a format that was developed by Mozilla, and I think it's used, or like its primary function at Mozilla is to very efficiently send data structures from one process to another, like maybe between tabs and like tab managers in Firefox. But we discovered like, wow, if you use bin code, especially for numerical data, like numerical data in JSON is like terrible. Like that's super inefficient. But if you use bin code data is potentially like an order of magnitude faster to parse than JSON, and even message pack, which is quite fast, is still doesn't hold a candle to bin code. There are some even more insane serialization libraries in Rust, which are really fun to read, but I don't think we'll use. Like Abomination. It literally says like, don't use this. This is like dangerous and not production ready because it's so unsafe. But basically, it's completely zero copy serialization, deserialization for common Rust data structures like vectors and strings and hash maps, etc. I think like I need to like dig into exactly all of the different data structures that it supports. But yeah, Rust's community loves making data fast and like using hardware really effectively. And instead of like building a completely proprietary data format that like, or like an entirely proprietary encoding like you might see in like Postgres or something, you can get really, really far using serialization, deserialization libraries that exist out there. So I think that was like actually a big surprise to me personally, was how absolutely critical it is to be able to parse data and encode data quickly. And there are just a lot of really cool options there in Rust, and way more that we want to continue to experiment with, because I think we can get even faster over time. But yeah, anyways, and like slightly better compression, but every ounce of performance we can eke out of it really counts when you're dealing with like petabyte scale security data lakes. So, but I think that was like, yeah, that was one thing about Rust that I was pleasantly surprised by, is just how awesome it was at encoding and decoding data, and how many options there were. Thanks to Serday, really, as like a framework that everyone seems to adopt.
Yeah, that's the crazy part about Serday. Like, I don't know, that might be one of the greatest libraries ever within Rust, because not only is it something that everybody needs to do, but it's just so versatile that you could just basically write a couple of kind of, I don't know what the heck those are even called, but it's like how to encode, how to decode, and then it just uses the traits and it can just do it for you. Like CSV, JSON. It's just like you just change this one bit and then you're done. It's like, wow, that was easy. Like yeah, it's insane.
Yeah.
But I mean, kind of going back to like you're talking about the storage format or the encoding decoding format. It to me it makes so much more sense unless you have a really really good reason to use some of these custom formats rather than, like you said, making your own. Because I mean, people spend lots of time on these, and open source communities do value kind of like working hard and trying to make some kind of standard that makes sense, and like why not lean on the back of that, and then you could focus on your work and kind of like you said, inking out the performance. And if you already have a data encoding format, encoding decoding format that works so performant, then just like leave it. And man, like if that is a bottleneck later on, then that would be the time to change it, right? Like right now you have more important things. I mean, I think one of the biggest ones is probably, at least in US and many other countries, is like the connection between like the client and the server. How can we
Hmm.
like speed that up? How can we compress that part? So I mean, is there like a double like compression where you say like, okay, can you actually compress the the what do you call that, the connection between the client and those services that have all your data, and also have that double, like the other compression would be the actual file format that you're talking about, like you have this kind of thing going, right?
Yeah. I mean, that's really interesting. You mentioned the web clients. So one of the things that we discovered as well, like one of the things that was surprising was we use WebSockets to make like the performance of the web app extremely fast to be able to send a huge number of streaming results back, so you can immediately start to see hits even if you're like traversing tens of terabytes of data. But we discovered like Rust really outperforms like AWS's services sometimes. Like API gateway would like fall over with too much data flowing over, which is what we were using initially, like Amazon's API gateway. But yeah, I definitely think, and one of the things that we're doing now is starting to play with WASM to send really cool like data sketch data structures over the wire to the client, so that and a data sketch is sort of like given a kind of like a complex aggregation query that does some cool like statistical function over the data. Oftentimes, if you were to store an exact result, you would need like to store gigabytes of data somewhere. But if you can use a data sketch, which gets you close, it has some error, but it's close enough that it's still extremely useful. So like a classic example is like, give me the IP addresses that have hit my service the most over the past 24 hours. Like you can use a really efficient data sketch data structure written in Rust, and use like something like a bin code, compress it with gzip, zstandard or something, send it over the wire, and then use WASM on the other side with Rust to merge multiple results that are coming in from the backend, so that you can. It's like the same exact sort of complex data structure on the client and the server, and you don't need to send a huge amount of data over the wire. Yeah, I think that's actually something that's really fun in Rust. Like I just imagine if you were to try to represent this in JSON and send that over the wire to JavaScript and kind of try to rebuild like a data sketch data structure, it'd probably be like 100 times bigger or something. I mean, I guess you can send like byte arrays over the wire and sort of play with JavaScript's like low level byte array sort of interfaces to deal with it. But it is just really fun to be able to take fairly complex data structures, get good compression performance, good encoding, and use the same format on the front end and back end. We have a lot more to do there. Like we haven't spent a lot of time with WASM. We've done a lot more in the past, experimenting and playing with WASM and really enjoying it. And Rust's WASM story is great, I think, compared to C and C++'s WASM story, or like the developer experience at least. But yeah, there's like a lot of really cool innovation you can do by using similar sorts of formats, like Rust, really efficient encoding formats on the back end and front end, and like Rust's and using similar Rust libraries on the back end and front end, so you don't have to like write your own custom encoding format. It's pretty sweet.
Yeah, I do want to get again kind of back onto the topic. So we I don't know if we actually really discussed more about how Scanner.dev actually works. So you still rely on the cloud infrastructure for storing the data and some other pieces. Do you mind to kind of talk about the architecture?
Yeah, absolutely. So this was really interesting. So we have like a blog post recently where we talk about pushing hardware to fundamental limits. So we felt like the problem that in particular security teams face is just there is so much data to handle, and it's usually a very small team at like a big company who has to deal with this. And a lot of tools require you to push data over the internet to another service. So like if you're pushing logs to Datadog, you actually end up sending them over HTTPS probably, and or maybe syslog, some of the protocols. But you are sending a huge amount of data over the internet, and there's a lot of egress cost. But one of the things that we thought about is, okay, so if you just take a big step back and look at how logs are stored now, you have teams like security teams, teams that are responsible for observability at their companies, storing a lot of cold storage logs in S3. And what we do is we launch a new Scanner instance in the same AWS region. And we work with you. You run like a Terraform, Pulumi, or CloudFormation template to provide an IAM role that gives us read access to that. So instead of pushing a huge amount of data over the internet, which is expensive, just that alone is really expensive, we just read it directly from your S3 buckets at like zero data transfer cost. And we have a bunch of Rust-based containers which build index files from the logs that you have in your S3 bucket. And then we push those index files back into your AWS account into another S3 bucket that you own. So all of the data is owned in your AWS environment. It's in your S3 buckets. You don't have to, you control not just your own data, but also the index files that we generate. And then when a user executes queries, then Scanner's Lambda functions spin up, and they have permission to go and read the index files in your environment. And again, zero data transfer cost, but you own all of your data. I think it's kind of like this interesting new world where like a lot of SaaS vendors require you to like push all of your data to them and they own it forever. And it's very hard you kind of have this lock-in experience. But now I think it's like sort of this collaboration that we have with our customers where they have a really cool set of logging infrastructure and sort of like log scheme that they have established in their S3 buckets. They might have their own custom tools that interact with it, or they might use Athena to go and scan it. But then Scanner can also get access to those and then make it much, much faster to go and search those by building these index files and saving them alongside your logs. And so, yeah, instead of pushing your logs to somebody else and spending a lot of money doing that, we kind of pull them or like we read them for you, analyze them, create these index files, save them in your S3. The index files are way, way smaller than the original data set as well. They're like 10 to 20 times smaller than the original data set. So it's not like you have to store a lot of extra data with Scanner. But yeah, it's fun. It's sort of like if you think about like, okay, what would be the most efficient thing to do with a massive log data set? It wouldn't be push it all the way out of the data center over the internet, travel across miles of wire, come all the way back in again, and then get processed by some vendor. It's like, no, everything stays within the network, and we use VPCs in AWS to have this like direct connection to S3 with no data transfer costs in the same region. So it's just like, yeah, it's there's just a lot of cool wins where it just seems to us that hardware this way, that using this approach, hardwares are used way more effectively, and there's not all of this like extra waste moving data all the way out into the internet and back in again. And it just really makes a huge difference because like the scale of the logging that everyone experiences is just rapidly growing year over year. And so whatever you can do to really efficiently analyze that at massive speeds, like, for us, like up to a terabyte per second, is really helpful. So yeah, that's like roughly how what the architecture looks like. Uh, and I guess like you can either run Scanner in a managed AWS account that we manage, or you can also deploy Scanner into your own AWS account if you really want to. Um, Most of our users all opt for us to manage. But either way, it's like it's quite flexible. We just sort of deploy alongside you and partner with you, as opposed to you like letting go of all of your data and doing a bunch of extra work to push it over the internet.
So it sounds like you're working a lot with AWS. Is AWS the only cloud provider you're working with, or because I mean you're talking about enterprises? A lot of enterprises use Azure. In fact, one of my clients, they're like, "Oh, we bought into the Microsoft chain, so yeah, we have to use Teams and blah blah blah." And by the way, let's not use Azure because it's such a pain in the ass for us to get our IT department to do it. It can be hosted somewhere else. Like that's actually what I hear a lot more. So are we actually able to run this on other cloud platforms such as GCP or Azure?
So right now it's AWS only. It is really interesting to see that there's decent feature parity. Like every year, they all seem to release similar kinds of features. So like Azure's blob storage and GCP's object storage type services also have like an S3 compatible API, and that's the most important thing for us is S3 compatibility. And they also have the ability to very quickly launch up serverless functions. There is a fair amount of work to do to like get it to use all of the bespoke cloud services in GCP and Azure. But yeah, it's really cool. It's very easy to create containers in Rust and have them be somewhat mobile between the different cloud services. But there is more work to do before we support GCP and Azure. AWS, though, it seems to us that the security story at AWS, we see a lot more pain there, where people feel like, using Athena is not fast enough. Like running a query over a year of data to generate a compliance report for auditors might take multiple days and cost a huge amount of money, whereas Scanner can make that happen in 30 seconds or something. Whereas I do feel like Azure has a pretty cool security story already with Azure Sentinel, and it's effective. It's like fairly expensive, I would say. Azure Sentinel is fairly expensive, whereas we really care about like reducing costs. We think like all this extra cost in the logging space is kind of ridiculous, and we just really care about efficiency. That's why we picked Rust, and that's why we use S3 for storage. But yeah, it will come for GCP and Azure in the coming years, but it's not there yet. We're focused on helping people in AWS right now.
Okay. Well, I mean, still you're going to get, I think, I guess we can kind of a little bit touch on that. Is there some customers you did lose because you're not able to deploy on Azure? Or has it just been like, okay, well, you can't, so let's just create another account? I'm guessing that the need for this is probably more important because the bill of Azure will be so much higher than what you would have without it, right?
Yeah, so we do have people who are like, well, what we'll do is we'll actually push logs into S3, or like we'll centralize our security logs into AWS, so that they might be like in a couple of different clouds, and they might be running their services in GCP, Azure, and AWS. But then they're like, okay, in order to get like a really good analysis experience, it's a lot easier to centralize it as opposed to trying to build something that can read from everywhere. So we do have some people who are pushing things to an S3 bucket and like kind of moving and centralizing security analysis in AWS. But I would love to. I think like someday it'd be really fun for us to say, cool, like you have an instance of Scanner that's like very cost efficient in each place, and it's quite interchangeable with containers. I think like it will take some work for us to reduce or to translate some of the AWS API calls that we make and use the appropriate SDK for GCP and Azure. But because they also like they're actually pretty good, Azure and GCP are pretty good at producing S3 compatible APIs. Like it isn't too terrible. We'll get there eventually. But I would love to be able to say, cool, like no matter where the data is, you don't have to transfer it over the internet to some new data center. Your instance of Scanner in each of your regions will return you the results in the like Rust compatible like WASM parsable format, and then your client can kind of aggregate them from each of your instances and give you results. That's like the dream eventually. But right now, there's so many companies that need this functionality in AWS and like fast investigations and threat detections that like there's plenty of work for us to do in AWS before we start to expand to other clouds.
So, my next question would be kind of like, what's the future of Scanner.dev? Like, it seems like you already have a working product. It's pretty optimized. Is it just that there's always room to optimize? It sounds like eventually you want to do multi-cloud support, but it's still farther down the the history or whatever you want to call it, the future. So, what is it that you're working on now, and for the upcoming like close future?
Yeah. So right now, I would say Scanner is a really good complement to sort of like these more established log tools like a Splunk or a Datadog, where you might keep 30 days of logs in Splunk or Datadog, and it has really advanced functionality that they've been building for, in Splunk's case, for like 2 decades. And Scanner provides a simpler query language with like simpler kinds of things that you can do with it, but you can execute queries over a massive amount of data. But we are increasing the sophistication of the query language a lot. I think like you can really get to 80% of the functionality of some of these really, really expensive tools with just implementing 20% of the query language features that are the most important. And so our focus right now is making our basically our aggregation and analysis aspects of our query language way more powerful. So we can do simple kinds of aggregations right now, like search for all of these hits, but then aggregate it into a small number of values. But in our coming like release in the next month and a half to 2 months, it's going to we're making our aggregation system really flexible, so you can compute generate new tables with each step of your query, transform it, and compute like multiple statistical functions over your data at the same time in the same pass. It's hard to do, but it's really cool. Like Rust makes a lot of this like really fast and simpler than otherwise, and the libraries there are really cool. So that's another really important thing. The next is really awesome detection rules supporting Sigma is this really awesome open source project that has a huge list of common detections that you want for different services to basically this crowdsourced repository on GitHub of really good detections. And there are lots of other open source detections that we want to support. So like really good detections out of the box and faster data connectors to different like log sources. So you don't have to push logs into S3. We will help pull them into S3 for you is coming. And I think the future probably like one of the things that we're researching. I think like it's way too early, but one of the things that we're excited about is like detection rules that don't rely on domain knowledge, but can use things like embeddings, like using vector databases to find similarities and clustering of log data, so that you can find weird anomalies with these really cool new vector databases out there. I think this is definitely there's some really cool Rust based vector databases that maybe will like I don't know, we're maybe a little too biased in favor of Rust, but that could be really exciting to play with. It's very very early, but I think like that's where things are heading. I think like where things we see the way that see things heading is that developers are going to be much more responsible for security in the same way that they have become more and more responsible for ops. Like running their infrastructure, they're going to have to now protect it. It's very easy to accidentally deploy like a Terraform script that like opens up a bunch of permissions that you didn't realize in your cloud infrastructure. And I think like we want to be there to make it so a lot of that's taken off of your plate, and we will automatically enable things like CloudTrail audit logs for you. We will analyze them for errors and signal weird things that are happening in your environment that seem anomalous. Let you investigate them and start to integrate with your like custom webhooks with Slack, et cetera, for when these threat detection alerts go off. And and help you really like very quickly identify and fix them. So yeah, but it is like an interesting responsibility and burden that I think developers are going to increasingly carry, which is like, wow, in addition to having to build the application and run it in the cloud, like, and know how to like build infrastructure, I'm also going to have to learn like how to protect it better. Like, but that's where things are going to go. And I think like in the same way that cool like infrastructure as code tools have made DevOps easier for developers, I think like tools like Scanner that are very easy to use with a lot of power out of the box are going to help developers protect what they have without spending a huge amount of time on it. So yeah, I think like it's just frightening how easy it is, or like, you know, how many breaches there are, and it's just incredibly important to be able to understand massive amounts of data very quickly to stay protected.
Awesome. Well, we're approaching the end of our time. I mean, we can go on and on about this stuff for forever. We have to say goodbye at some point, though. But I mean, is there something that you want us to know about Scanner.dev, or maybe we should come check it out, or anything that you wanted to say before we sign off?
Yeah, absolutely. So like if it's interesting to you, we would love for people to come check it out and try it. We have a lot of fun features coming. But also, like, if you just want to drop a line on Twitter or LinkedIn and talk about Rust, we love that. We've really enjoyed working with other, or like chatting with open source contributors, like to really amazing crates like regex or actix or like Aho Korosik. There's some like really amazing people in the space. So if you just want to chat and ping us in socials to chat about Rust, we'd love to. And if you have like strong opinions about infrastructure at petabyte scale, like always love to hear everyone's thoughts. But if you would like fast search, even if it's not for the security use case, if it's just for application debugging, you don't want to ship your logs outside of S3, want to keep them there, like come chat with us. I'd be happy to meet up and hang out and get to know your problems. So that'd be awesome.
Cool. Well, thank you for coming on and talking about your experience with Rust. I almost feel like you like Rust more than you actually like Scanner.dev sometimes. They're very much related, obviously.
Yeah, well, I mean, I think Rust is really cool. I think like we're passionate about it. I think like it really does enable massive data infrastructure projects like Scanner.dev, and is going to be increasingly important in the future. Yeah, it's fun to see. It's fun to see like that trend going in the Rust ecosystem, and it really enables us to make a super efficient like security data lake solution, like unbelievably fast compared to Athena or CloudWatch for a lot of use cases. So we just really are grateful that Rust allows us to provide users with like way better performance and unlock like workflows they haven't had before. So yeah, I do love Rust a lot.
Yeah. Well, thank you for coming on, and hopefully we'll have you back on again in the future.
Awesome. Alan, thanks so much. Take care.
Yep.